In binary addition, we add numbers that use only 0 and 1. So basically, there are just 5 rules that you need to memorize in order to get this correct. So rule number 1 is 0 plus 0 is equal to 0. This is basic math rule as well, that 0 plus 0 is equal to 0. Rule number 2 is 0 plus 1 is equal to 1. This is also a basic math rule, that 0 plus 1 is equal to 1. The same vice versa, that 1 plus 0 is equal to 1. However, the rules are quite different for rule number 4 and rule number 5. 1 plus 1 is equal to 10. However, we can see in basic maths that 1 plus 1 equals to 2. How would we represent 2 in binary? Why does 1 plus 1 not equal to 2 in binary? Because we can't simply write 2 in binary. Here I have represented 2 in binary form. Here you can see the powers of 2, and underneath it I have written the binary form of 2. So 2 is 0, 0, 1, 0. I've only turned on the 2 here. So that's why the 2 in denary is represented as 10, or we can say 10 in binary, which is this number 10. That's why 1 plus 1 is equal to 10 in binary. You have to memorize this. Rule number 5 is the same case, that why 1 plus 1 plus 1 is equal to 11 and not 3. Now I'll do the same thing for 3. We know that 1 plus 1 plus 1 is equal to 3. So I'm going to make a binary number using 3 like this. So how is 3 represented in binary? You know that 2 plus 1 is equal to 3. So I'm going to turn 2 on and 1 on. And here is my number. That is why it is equal to 11. 3 is represented as 1, 1 in binary. Okay? So rule number 4 was 1 plus 1 is equal to 10, and rule number 5 was 1 plus 1 plus 1 is equal to 11. Once you memorize these rules, you are going to get everything correct. Now, one very important rule is like just normal addition that you do in denary numbers. You have to always start from right and then move to left like this. Okay? So now let's do an example of addition of these two binary numbers. Okay, so you need to see this, and there are some other rules that you need to remember as well. So what was 0 plus 0? It was just simply 0. What was 1 plus 1? It was 10, right? 1, 0, right? However, this 0 is going to go into the sum part, but I am going to carry the 1. Okay, so I'm going to write 0 here, and the 1 is going to be carried here. Now you can see there are 3 ones here, 1, 1, and 1. We saw in the rule 5 that 1 plus 1 plus 1 is equal to 11. So I'm going to write 1 here and 1 carry, because I get 11. So 1 goes into the sum part and the other is going to be carried away. So here I carried this other 1. Okay, so now again I have the number 1 plus 1 plus 1. Again I get 1, 1, 11. Okay, so it's going to be 11. Now here you can see it is 1 plus 0 plus 1. Ignoring the 0, you can see that 1 plus 1 is equal to 10. Again, 1 plus 1 is equal to 10, so 0 is going to into the sum part and 1 is going to be carried away. Now you can see 1 plus 1 plus 0. Ignoring the 0, 1 plus 1 is equal to again 10. 0 here and 1 carry. 1 plus 1 plus 1 is equal to 11. 1 sum and 1 carry. finally we have 1 plus 0 plus 1. Ignoring the 0, 1 plus 1 is going to be 10. So I'm going to write 0 here. However, there are no numbers here to carry, right? So this becomes the overflow digit. Alright, because we are only allowed to have 8 bits here, because this one also contains 8 bits and this one also contains 8 bits. So we can only have 8 bits in our register. The one here goes away and get discarded. This is our finally. Now one final rule that I want to tell you, that in rule number 4 and rule number 5, 1 plus 1 is equal to 10. 0 is always the sum and 1 is always carried. And here 1 is here the sum and the other one is always carried. Okay, so this is sum and this is carry. This is sum and this is carry.